Greetings everyone and welcome to my channel. In this video we are going to talk about logistic regression. Do you know that you can know whether you will pass or fail your next exam using machine learning? Suppose we have a dataset that contains information about students' exam scores and whether they passed or failed. We can use machine learning to model the relationship between the exam scores and the probability of passing. The exam scores are called independent variable. The probability of passing is called dependent variable. A logistic regression model will help us predict the likelihood of a student passing the exam based on their scores. A logistic regression is a supervised statistical model, which means that we have a labeled input data and output training data. It is used to predict the binary outcomes, whereas the dependent variable is categorical and has two variables, true or false, yes or no, 1 or 0. It estimates the probability of the outcome, which is passing or not passing the exam, based on the values of the independent variable, which are the exam scores. Another example of logistic regression is to predict if a species of bird will be present in a given area based on the temperature of that area. We can collect data based on the presence or absence of the bird and the temperature of that area and apply a logistic regression model. The equation for a logistic regression model is Py equal 1 given x equal to 1 over 1 plus exponential minus c, where z equal log p over 1 minus p equal to beta 0 plus beta 1 times x. The log p over 1 minus p is called log odds, where p is the probability of event to happen, which is the bird being present. X is a predictor variable, which is the temperature of that area. Beta 0 is the intercept, which is the value of the log odds when temperature equals 0. Beta 1 is the coefficient, which is the change in the log odds for every 1 degree increase in temperature. Using this model, we can make predictions about the probability of a bird being present in an area with a given temperature. If the temperature equal to 25 degrees, so z equal to beta 0 plus beta 1 times 25. In the case of the model coefficient are beta 0 equal to negative 2.5 and beta 1 equal 0.2, then z is equal to minus 2.5 plus 0.2 times 25, which is equal to 2.5. By coming back to our equation, p equal 1 given x equal 1 over 1 plus exponential minus c, probability equal 1 over 1 plus exponential minus 2.5, which gives 0.7. This means that we have 70% probability that we can find our bird when the temperature is 25 degrees. Now let's implement a logistic regression example in Python using scikit-learn library. In step 1, we import the necessary libraries including NumPy for numerical operations and logistic regression from scikit-learn for logistic regression modeling. Then, in step 2, we create a simple dataset with two independent variables x and a binary dependent variable y. In this example, we create x as a 2D array representing exam scores and y as an array indicating pass 1 or fail 0 outcomes. Step 2, create the dataset. In step 3, we create an instance of the logistic regression class and train the model using the fit method. This step estimates the coefficients of the logistic regression model based on the training data. Step 3. In step 4, we use the trained model to make predictions on new data points, x new for example, using the predict method. Additionally, we can obtain the class probabilities using the predict proba method. Step 4. Make predictions. In step 5, we print the predictions and probabilities for each new data point. We make loops through each data point in x new, and then we print the data points, the predicted class 0 or 1, and the corresponding class probabilities. Step 5. For I in range len x. As we can see with the new data point 2.9, 2.7, the predicted class is 0, and the class probabilities are 0.6 and 0.39. The new data point 1.5, 1.2, predicted class is 0, and the class probabilities are 0.58 and 0.41. You can modify the code by providing your own dataset with appropriate independent variables and binary dependent variable. Also consider performing data processing and evaluating the model's performance using metrics like accuracy, precision, and recall. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.